Right. I think we're good to get started if you are ready.
I'm all set.
Sounds good.
Thank you so much. Good morning, afternoon, evening, wherever you are. So, my name is Chanchal Chatterjee. I'll make a brief presentation, and I will probably be doing some presentations tomorrow on the coding side. This is a very hands-on session. I want to deeply thank Timothy Ma, who is my colleague, who will be helping you set up your Quick Labs Google Cloud Platform access. He has generously donated his time to help us through this session for the next 1 hour. Elvin Zhu is my colleague who is a extremely professional software engineer at Google, one of the best. He will be doing coding exercises after the presentation that I finished the slide deck. And so I'll give you a schedule and how we proceed from here. Hopefully you all can hear me. The first thing I would like to mention is that there is a link I have distributed that is there in the chat window. Please go ahead, fill in your name in that if you haven't, so that we can get you access to the Quick Labs, which is our Google Cloud Platform access. And Timothy will be working in the back end to set you folks up. Okay, so going back to the slide presentation. We are going to talk about what our vision is. And then we are going to talk about two steps in our vision, which is build a prototype and build a pipeline. And if you have any questions, we'll take question answers. So the first 20 to 30 minutes will be just this, the slide presentation. So the introduction, we have a two-part. First part will be today. The second part will be tomorrow. Typically, what we do is that we do what we call the prototype or the POC. So any ML project, we envision that it consists of two parts. So you have a use case. The whole idea is to go from your concept of the use case to the production, that whole journey. How do we do that? So you have a use case. Let's say we are going to take up a couple use cases. Like one is how to find risk of lending. Okay, so we are going to take Freddie Mac data and we are going to show how you can predict it to certain customer, what is the risk level. The second example we'll take is that we have some images and we'll do classification on it, like digits 0 through 9. So you have this use case. So the first step is how to build an example. So this is where Elvin will go through the lending risk. I'll go through the image classification examples. One is in XGBoost, the other is in Python. So we could do all of this with XGBoost or scikit-learn or Python or TensorFlow, any of these platforms, ML platforms. So how do you build the model? So that's the part one. Part two is once you build that prototype in a Python notebook, in your cloud account, how do you take it to production? And that is the Kubeflow pipeline, and that is tomorrow. So today is how to build the prototype, and tomorrow is how to build the production pipeline. The pipeline will have all the components that you have built, and I'll go through some of the examples of that. And then you'll have orchestration and how to build this entire pipeline end to end. So this tutorial, you'll have hands-on experience building the model from concept to final production-ready ML pipeline. You can also call it staging. The tutorial will be implemented in the Google Cloud Platform. That's what Elvin, Tim, and myself have access to. Models can include XGBoost, TensorFlow, or scikit-learn model. Time permitting, we'll certainly cover XGBoost. Time permitting, we'll cover TensorFlow. And I don't think we'll have time to go through scikit-learn, which are much simpler models like SVM and others. So you could easily pick it up from here. So conference link, we don't have to go through that. And the Quick Lab instructions. Timothy, do you Do you have the QuickLab instructions embedded in the QuickLab account, or do I need to distribute a PDF version of that? How are we doing this today?
A PDF would be nice just to send out to everybody. I think these instructions might have come with the email, but they're fairly straightforward. If we want, we can take probably 5 minutes to actually go over this. But I do want to make sure has anybody filled out the form. If anybody hasn't, please go ahead. Chanchal has put the link here on the chat. You're going to need that to create your QuickLabs account. Yeah.
So this is the form. I'm going to send it in the chat window again. And that's the form. Please fill it out as soon as possible. And then for us, did you have a chance to distribute the QuickLab to the attendees, the QuickLab instructions, or how should we do this?
Yes, we did. Yeah. So we did send the PDF out to the attendees, but I can put out the link just to make sure that we send it again.
So I sent a PDF. I don't use Zoom a lot. Can I include a PDF in here? Can I drop a PDF in the message window, or I cannot?
No. So there is a way to share files, but I do have the PDF saved on my drive, so
okay,
I can share.
Awesome.
Yeah, just 1 second.
Yeah. So, well, for us, it's sending that. This is the setup instructions. Looks like quite a few people already got this. I sent it out this weekend. So the form, filling out the form is important, and going through these steps is important. So that's what we'll do for the next 1 hour once I finish my little slide presentation. And this is the step-by-step setting up we'll do. So let's hold the thought. Let's focus on the steps first. So that's the QuickLab instruction. And this is the schedule. The schedule that we will have is that I'm doing this 20-minute overview, then Timothy will do the 60-minute setup. So I would guess that after the QuickLab setup, we'll take a 10-minute break. So right now it's around noon in Santa Clara, which is Pacific time. So it's probably 3 p.m. in the Eastern time. So after 1.5 hours, which is 4:30 Eastern time and 1:30 Pacific time, we are going to take a 10-minute break. And then Elvin will come in and do a 2-hour presentation for the XGBoost models and stuff. And for that, if you want, we can do a break after the first hour. He can do XGBoost and or TensorFlow within these 2 hours, he can decide. And then tomorrow, we are starting at 10 a.m. Pacific time, which is 1 p.m. Eastern time. And we'll go through the Kubeflow pipeline, and we will see if we can do a Kubeflow pipeline for TensorFlow as well, if time permitting. But we are going to give plenty of time. The whole idea is for the team to not rush through the tutorials. Of course, we have worked through all of these, and we can just click the cells and finish everything in 30 minutes. But the idea is for all of you to actually use your notebook and click through the cells and what problems you encounter, address those problems. Hence, we have kept 2 hours instead of 30 minutes. Okay, so that's the schedule. And the schedule is also kind of flexible, and we can switch around based on people's needs. So what will you need? You need the QuickLabs account, which Timothy has graciously been able to set up for you. He's setting it up as we speak. You need to have Python knowledge. You need to have TensorFlow and XGBoost knowledge, which is ML. And you need to also brush up on Kubeflow pipeline. So that's the other thing. And I can send a PDF version of this presentation for you to look it over, these links. So what is our vision? So like I said, we are going to have 2 parts and 2 steps in how to go from a concept to production. First, we start from a use case and we build a stable model. So that's today. So this is where we build a prototype, use an acceptable ML use case, essential GCP infrastructure setup, internal technical teams are ready to build the model, which is you folks. And then once the model is obtained, this is at the end of today's presentations and all the hands-on work, you'll have a model with an acceptable performance on the data. And you will have the modeling pipeline will be tested in a Python notebook. This is not the Qflow pipeline. This is like step-by-step building the model and making sure it works. You can train it, you can hyperparameter tune it, you can deploy it, and you can do online prediction. Now you're ready to deploy. So here we create a Qflow pipeline in order to create the ML pipeline on your GCP account and deploy all the components that we have built as a full end-to-end pipeline, as a scalable, composable, secure pipeline on your GCP account. Okay, I cannot see the comments because I'm on full screen mode. If there's any comments for us or someone, please interject me and please pose the questions. Okay. So your ML journey, the proof of concept.
Hey, Chanchal?
Yeah.
Sorry to interrupt over here. I see a couple people asking questions in terms of access to the Quick Labs. Yes, after you fill out the form, after everybody, make sure you create a Quick Lab account with the email that you sent over. Once you create your Quick Lab account and you're in there, I will activate the lab. I haven't activated yet just because there's still some signups right now, but you will get the credentials to actually join or actually have your GCP console or project access to your GCP console afterwards. So go ahead and, after this, after Chanchal has completed the presentation, just go to Quick Labs, create it, and I will get it started. But yes, your temporary credentials for Google Cloud created in Quick Labs will not be generated yet.
Awesome. Thank you, Timothy. Feel free to interrupt me anytime. No need to apologize because this is an interactive session and there'll be a lot of issues as we go along. So the idea is that in the proof of concept, we'll define a use case, we'll build the model, we'll validate the model on realistic data. And for the XGBoost model, we'll use the loan delinquency, that is the risk of lending model. For the images, we'll use like digits, MNIST digits to classify them. Then in the production stage, we'll create a production pipeline components and build the Qflow pipeline. And we'll do test and monitoring of that. I don't think we'll have time to cover test and monitoring, but at least we'll be lucky to have the Qflow pipeline fully operational at your end. Maybe we can do a separate session sometime in the future on test and monitoring, which is a big, vast topic. So revisiting the steps, optimize the data, prove the model, build the production pipeline, prove the pipeline, and test and monitor. So I think we'll cover the first four in this session. So this is sort of a production pipeline looks like, a typical example. You have input coming in real time, maybe from PubSub is our interface. You can have Kafka or any other real-time interface. You can have batch data from cloud storage. You can have tabular data in BigQuery, which is a data warehouse on the Google Cloud Platform. So we are using this Google Cloud Platform terminologies because that's what we'll be using today. That's what we have access to. We are not saying that you are restricted to GCP, but that's what we know best, and that's what we can give you free training today. And then the data preparation is the first block. That is what we'll be doing next. And then hyperparameter tuning, model training. Then we can do model deployment. Model deployment creates an endpoint for the model. It makes the model into an API. It stores the model into a model repository. You can version the model. You can label the model. You can also do model explanation. We won't cover much of that. And then you can do model prediction. And there are two types of predictions. One is batch prediction. The other is online prediction. So ML pipeline that we are building, this end-to-end, first the prototype, then the pipeline. It should solve your use case. It should start from scratch and use pre-existing models or build your model. It should be easy to deploy. You should be able to onboard your model, and Elvin will show you how to build the Qflow pipeline. It should be scalable, and as the workload changes, you should be able to compose them easily. You should be able to orchestrate them, and then it should be secure. So those are the key properties. And one of the important properties is scalability in most of production environments. Security is equally important. So the whole idea of composability, so scalability is because your data load changes, it can go up, it can go down, and then you should be able to scale according to that. Composable, that is very important, because if you want to do, let's say, training on the Google Cloud, and you want to do prediction on an on-prem environment, let's say you're a bank and you have a lot of PII data that you don't want to put in any public bucket or any cloud environment, you want to keep it secure under lock and key inside your building, then you want to do certain type of processing only on-prem. And in that case, you should be able to take, let's say, the data prep could be on-prem. And how would you take these blocks and compose them in separate places and put it together? Google has a framework called Anthos that helps you do that, but we're not going to cover all that, but I'm just giving you a flavor of what composability means. So going to all the machine learning components, these are units of the pipeline that we'll be building. We'll implement the following components in the ML pipeline with Kubeflow. So the first one is data ingest and pre-processing. Second one is model training. Third one is hyperparameter tuning, model deployment, model prediction, which is online and batch, model explanation, and training orchestration. So what is training orchestration? This is a complex topic, which is how do you start or trigger the training process? How do you manage the training process? Like, do you want to trigger it on a certain scheduled time? Do you want it to be triggered by the user, or do you want to be triggered by a certain amount of data input? Or do you want to version the model in a certain way? Do you want to keep track of your dates and timestamps, and all of that? So this whole orchestration process of the training process, how do you trigger it? How do you store the data? How do you store the models? All of that is part of training orchestration. So we will try to show you some features like images and tables. I don't think we'll show custom cost functions. We'll only operate in CPU, although in general we can operate GPUs, and Google has the specialized processing units called tensor processing unit. We won't be able to show you that because your account doesn't have that level of permission. A model deployment will show online predictions. We won't show large models because it takes a long time to train large models, sometimes 10 hours, 12 hours. We certainly don't have that time. We won't like small models which can be trained in under 10 minutes. We'll optimize model size and performance through hyperparameter tuning. We'll show you that. We'll show predictions and images and tables. There's another way to do that, which is called TF recurse, which we don't show. We'll create model versions mostly on global endpoints, although you can easily turn it around and do regional endpoints. Okay, so these are things that we will be showing, which is a lot of material. So how do you build a prototype, which is step one, which is the hands-on workshop for today, which is to implement the key modules. Build and train models, deploy models, predict model, and explain the models. Unit test all these modules. Okay, that's what we'll be doing. So in this, we are not building the pipeline, we are not orchestrating. So this is the prototype, is to build all these components and unit test them on your data and on your use case. So revisiting, these are the things. And then more description, we'll have preprocess.py, predict.py, all these will be the little input functions that will. So we'll build these modules, we'll divide them up into little functions, and then we'll be building the Kubeflow pipeline. So each of them can be divided up into separate modules, separate functions. It can be separate Python files, or it can be just separate Python modules, and then you could deploy it. Okay, how do you create a deployable ML pipeline in Kubeflow pipelines? So there we'll set up the training platform. We'll set up a GK cluster. That is the lesson for tomorrow on the quick labs. So you don't have to finish it today. Today we should be able to set up the notebook and start working, but we'll have to set up the GKE cluster for tomorrow and deploy the Kubeflow pipelines on the cluster. We'll create the Python function-based components. We'll define the input outputs of the components. We'll compile the function to components with a function called func to container op. Then we'll create custom Docker images or Python modules, and we'll push these images into container registry if we create Docker. If we do Python, we don't have to. Create the pipeline with the Kubeflow pipeline DSL, and then upload the pipeline as a tarball to a GKE cluster, and you can run it with a graphical user interface. You can see it all with a graphical user interface. So here's an example of a very nice graphical user interface that you'll have in the Kubeflow pipeline. Google Cloud Platform, this is the managed version where you can see the data pre-processing, the hyperparameter train, the training, the deploy, all these will be graphically shown. Okay, sorry, I'm going a little fast because I'm exceeding my time. This is an example of how a global model explanation looks. You can also have local explanations of feature importance. The global explanation shows the feature importance, how these different features contribute to the output. You can have local explanations, which shows how a particular sample of data or a small batch of samples, what was the reason for this output that you got or the outcome you got to the model. Global explanation is on the entirety of the data showing the results. Monitoring is another topic. So model explanation, monitoring, a deep topic. So I don't think we can cover all of that, which is monitor, relate, diagnose, and update models. Okay, sorry. That's it for me. And I'll turn it over to Timothy to help set up the rest of the team's account, Quick Labs. So I'll stop sharing.
Actually, Chanchal, can you say the instructions you have pulled up? That'd be great. So we have not started a lab. Actually, for folks, I've been privately pinged by multiple people here. We have not started yet. Please go ahead and create your Quick Labs account. So once you have your actual Quick Labs account, once I start it, feel free to refresh your page and you should see the modules up and running. So for those of you who are in Quick Labs right now, the reason you haven't seen it yet is just because we haven't activated it. So I'll wait here for a few more minutes. I'm going to give everybody 2 more minutes. But remember, the email that you signed up on the Google Forum for is the email you want to use for your Quick Labs. One important thing is when we start this Quick Lab, do not end the lab. And be sure to actually copy your credentials, these temporary credentials that Chanchal is actually sharing on the screen. Copy them and hold them somewhere in case somehow, some way you get locked. If something doesn't work for some reason, you get some pages loading or it's on a different account, Google Incognito window is your friend. Try that if you run into any errors, but I will take 2 more minutes just because I still see some emails streaming in here, but everybody go ahead. If you have not created your Quick Labs account, please feel free to create it now.
Yes, so the temporary username is the student01 blah, blah, blah. Copy it, password, copy it, GCP project ID, copy it. These are 3 key assets that you should keep. Do not press the end lab because that will end your lab. You want to keep it open for the entire 2 days. So Elfin and I have been doing some last-minute switch from AI platform to Vertex AI. I'm wondering if there are new APIs that need to be enabled because of Vertex AI.
Hey, Chanchal, yeah. I think people need to enable Vertex AI as well for the demonstration purpose. I'll just go ahead and figure out which API they should enable.
Yeah, so this is the Vertex AI. So when you click here on the
button and just click the button enable API, it should be good.
Correct. So when you go here on the left, I would recommend that when you, so this is click the pancake over here, and this list will come up. And then you could find Vertex AI over here, pin it, click the pin button. If you pin it, it will show up in the top. Usually I pin Vertex AI, Cloud AI Platform, and Kubernetes are the three things that I like to pin it, because those are three things we'll be using. So once you go here, when you click this, you won't get a screen like this unless you have enabled the API. So you could enable the API right here. Since I've already enabled, I don't have anything to enable, but if you need to.
Is anybody, has everybody created their Quick Labs account? If anybody hasn't, please let us know now. All good? Okay, I'm going to activate the lab. Everybody who is on the call now, feel free to refresh your Quick Labs screen and you should be able to see the module. If you don't and you have signed up, please let us know and I will add you again if need be.
Awesome. So this is the step where we want everybody to be on board. And we want everybody to be functional, because if you're stuck here and you're struggling here, you'll fall behind on the lab. So we want to take till about 1:30, which is next 1 hour, to make sure everybody's on board.
You should be able to see the module on your home page. It looks like folks are not seeing the module. One moment here.
So maybe for us, you can help us email to that list of attendees. I can give you access to this list if you want to. Give me your email for us.
Sure. So it's going to be Faraz, F-A-R-A-Z.
That is the email. Oh, sorry. Please go ahead. But the website where you signed up is c.quicklabs.com.
Yes, but I'm requesting for us to collect all these emails and send the instructions to the whole team by email. Is that
yes? Yes.
That,
okay. Yeah, I think you should go ahead and do that too. But I also posted that. I think if folks are created account on that.
So this is for us. I just gave you access to this Google Sheet that has all the emails. You could copy the email column and you could just send everybody, the 70 of them. This is why I had initially said that we don't want more than 30 people, because it becomes very unmanageable at some point.
Right, absolutely, yeah. So did you just want me to send
that instruction, the instruction PDF that I sent you?
Oh, just a
Saturday.
PDF, yep.
Yeah. So that instruction PDF, I think the slide deck is not that necessary right now. They need to set up the Quick Labs.
Sounds good. Just 1 second.
The c.quicklabs, I think, might be different. If the folks have actually created a Quick Labs account, it should work on c.quicklabs. That might just be a different URL. Folks, if you actually go ahead and refresh your homepage, you might be able to see it. Otherwise, feel free to actually take that, the module name again, and give it a try.
So for us, you have access, right?
Not to the platform itself, but I'm just accessing the sheet.
No, I mean they access the sheet.
Yep, I do.
Okay, so I do see it's working for some other folks over here. And Natasha, looks like it does seem like you have to sign in for c.quicklabs again. It might just be, I'm not sure if somebody posted another link for the regular Quicklabs URL, but go ahead and sign up for c.quicklabs again if it doesn't work. Yep. And don't worry, folks, Chanchal and I, Melvin, we won't be going anywhere.
Yeah,
So,
we're not moving ahead till everybody has access. That's important. And those who already got access will probably be bored for the next 45 minutes. So please bear with us. We want everybody on board. Yeah, I didn't know how to communicate before everybody signed up. That's why I sent the PDF for us, but even he didn't have access to all the emails that we are getting now.
I do see some questions regarding Vertex AI. Chanchal, why don't we do this after everybody's done actually getting access to it now? Let's just go ahead and walk through the Vertex AI enabling portion again.
Okay, so Elvin is getting a fresh Quicklab set up. I don't have it, so maybe Elvin can share the screen and show how to enable the API. Elvin, do you have the Quicklabs access yet?
Hey, Chanchal, I was disconnected. Sorry. What's the question again?
So the question is, when I go to my Vertex AI, I have full access, but if you start in a Quicklabs, you probably have a screen where you do not have access. So you need to click an API, enable API. I'm assuming there will be an enable API button over here.
Right. Let me see. I'm starting a Quicklab as well, so I can see from the audience perspective and see which API should I enable.
Yes. So can you share your screen and maybe you can show how to enable the Vertex AI API and the Jobs API? Yeah, we did a last minute switch to Vertex AI and that kind of complicated stuff, but it is good to know Vertex AI rather than Cloud AI platform because Google is wholesale transferring over to the Vertex AI. So we'd like to know if someone is still struggling to get onto ce.quicklabs.com. Okay, so some people are still not seeing the lab.
Please make sure, I'm going to post this here again, that you are. And make sure that the email that you signed up for on Google Forms is the same one that you are registered for Quicklabs. So the same account, the same email account that you signed up on that Google form or submitted must be the same account that you signed up for Quicklabs on.
So Elvin, can you see it at your end? Okay, Elvin is all good. Great. So obviously the process works. Yeah, so let's hang on for a minute.
For people to, we're still waiting for people to get access to the Quicklab GCP account.
Correct. So let people get access to their GCP account, and then you can show how to turn on the Vertex AI and how to turn on the Jobs AI in a live demo. For us, is also sending the instructions on.
Yep, it's already been sent.
Yeah, so if you're
Yeah,
the lucky ones already
one.
have access to QuickLab GCP account, once you're in the GCP console, you can just go click the sandwich button and find Vertex AI there. You can also search in the search bar on top of the console. Search for Vertex AI. That will bring you to the Vertex AI UI as shown by Chanchal here. So if you haven't enabled Vertex AI API, you will see a button that says Enable Vertex AI API. Just click the button to enable it.
I still do see people who are registered, but they have not created a ce.quicklabs account. Please make sure again that you are registered with ce.quicklabs.com. Yeah, not sure where the run.quicklabs.com came from, but yes, c.quicklabs.com. Please. Yeah.
Please don't make up your commands. So anybody does not have Quick Labs activated?
If you have created c.quicklabs.com account and you still do not have access, please let us know. Otherwise, I think we'll pass it to Elvin to start. I see Amar. You Cream question, folks. Create an account on Quick Labs. Amar, did you create it on c.quicklabs.com?
Yeah, there's nothing called run.quicklabs.com. Please ignore that message.
Yeah, another tip is if you already use the Google GCP service, you'll probably have your own credentials for GCP that will be conflicting with your QuickLab username and password. So just to open a incognito window and enter your QuickLab credentials there, it will be good.
Okay, how do you get to vertex.ai? You click this pancake on the left and scroll down all the way till you see Vertex AI and pin it.
Right. So just click the sandwich button, find the Vertex AI under artificial intelligence, and there's a big button saying Enable API. Just click it. Or you can do a search in the search bar in the middle and search for Vertex AI, and it will bring you to the same console UI here.
Correct. So the key thing that Tim said is if you're still having trouble, go to an incognito window and type in ce.quicklabs.com.
Yeah. So Amar, you have to fill out the form with the email. That's the only way we can add you there. But I just did it manually, so you should be good to go. Anybody else having any issues?
Yeah, we never sent out an email for the form because we didn't know who to send it to. We don't have access to your email. So as you guys are signing up right now, we are sending you activations.
Is anybody else having any more issues?
Okay, Amar got through. Anybody else? Okay, if not, we are going to go to the next step, which is to activate the Jobs API and the Vertex API. So, Elvin, do you want to show your screen and show how to activate those two?
Chanchal, I do have the same exact screen with yours, so I can share my screen.
Oh, so you're saying there is no need to activate?
Yeah, so if you can see my screen, I also have this my quick lab GCP project. I think it's still coming up.
No, I can see your screen.
Oh, you can see. Okay, cool. So this is my quick lab GCP project. I just click the sandwich button and scroll down, find the quick lab one. Sorry, find the Vertex AI under the artificial intelligence. The thing is, you can pin this one, so it will always be on top, right here. So next time you want to get access to Vertex AI, it's much faster. So go to the dashboard. At this place where my mouse moves, should be a big button, blue button saying Enable API. Just click that button, it will enable the Vertex AI API for you.
Hey, Elvin, I'm not sure if it's just me, but the audio is a little bit choppy on our end.
Yeah.
Okay, sorry. Let me see if I can change my input.
So might as well activate the Jobs API because we might do some projects with AI platform, then that will be, yeah.
So the audio is better now?
Are you using wireless headset or?
Yeah, I'm using, I just switched from my webcam microphone to my wireless headphone microphone. I'm not sure if it's better or worse.
Wireless.
Yeah, it's a little bit worse. My experience actually working with Zoom is that you actually, and it might just be, I'm not sure if you have a Mac or not, but yeah, the best way you might want to do is just wired in or actually just use your own laptop speaker, so nothing wireless.
Yeah, how about now? Is it better?
Well, not the same.
Still, yeah, still choppy.
Sorry, still choppy?
Are you using wireless still or the laptop?
No, right now it's wired. It's wired input.
Okay, let's go with this. So let's activate Vertex AI and then also go to AI platform and activate the Jobs API. So Elvin, can you show the AI platform Jobs API, please? So you go down.
Yeah, so under the same category, artificial intelligence, you should see both Vertex AI and the AI platform. So the AI platform is just an old version of the Vertex AI. And
then click Jobs.
Here, you go to the Jobs.
And then enable the API. So go to click the pancake, go to AI platform, pin that to, then go to Jobs and click Enable API. Okay, what is the difference between AI platform and Vertex? So AI platform is the machine learning engine that Google had for the last several years. Vertex AI is an enhancement of AI platform and is the new edition of AI platform that is coming up. That is mostly GA. There's some beta aspects. So we are also in a state of flux. Elvin, myself, and Timothy. We also have some code in AI platform, some in Vertex. We are trying to give you the whole lesson in Vertex. So Vertex have integrated AutoML tables with custom machine learning algorithms or AutoML, all the AutoMLs, and custom machine learning. We are doing custom machine learning. We are not using AutoML today. Okay, so if you have enabled Jobs API and Vertex API, then we have completed the next step. And then next is to start a notebook. So go to Vertex AI. Don't go to AI platform. Go to Vertex AI and click the notebook. So maybe I can share the screen, Elvin, if you want. So let me know when you can see the screen. My screen. Okay, can you see my screen?
Yes, we can.
Okay, so when you click Vertex AI, you get Vertex AI. See this notebooks? You click the notebooks. Okay, then you create a new instance. You click a new instance. And the one you want to choose is TensorFlow 2.1. Very, very important that we choose TensorFlow 2.1 without GPUs. Okay. So TensorFlow Enterprise 2.1 without GPUs. So once again, repeating, under Vertex AI, click Notebooks, click New Instance, click TensorFlow Enterprise 2.1 without GPUs. And it will take a few minutes. Okay, once you say click this, then you'll have to give it a name. You can keep the default name, or you can give it your name, like I can say Chanchal's 2.1 or something like that. You cannot put apostrophe, but I can say Chanchal -2-1 or something like that. Okay. And you don't have to do any advanced option or nothing. I would recommend that you set it up as US Central, because that has the most resources. That region has the most, at least that's how it used to be. Google GCP is evolving so fast that we don't know anymore. So this is what you should do, US Central 1A. Okay, I don't think you need anything else. I don't think you need to put too many CPUs or any more than 100 gigabytes, and then just say create. Okay. So once again, under Notebooks, under Vertex AI, click Notebooks, click New Instance, TensorFlow Enterprise 2.1 without GPUs. Okay, 2.1 without GPUs, and choose US Central. And click Create. Okay. Anybody not in that step? Okay, somebody's saying, should we already have clicked the Start Labs and put the temporary credentials? Natasha is asking.
Yeah, so can you guys hear me, right?
Yeah, much
okay,
better.
Cool.
Evan.
So yeah, oh, awesome. So yeah, click the Start Lab button, and you will see your username, password, and also your GCP, your link to your temporary GCP project.
Correct.
So click the link
Which is
and
these
input
three
your, yeah.
Please copy these three things for future, because if tomorrow you lose this, this is your way to get back in. Take a screenshot immediately and copy these and put it into a notebook or whatever you have. Okay, so enable the Jobs API, enable the Vertex API, go to Notebooks, create a new instance with TensorFlow 2.1 without GPUs, and choose US Central 1. Then you click the Jupyter Lab. You click the Jupyter Lab button. Once you click the Jupyter Lab button, you can click plus and you can choose terminal. Okay, before I go there, is there anybody who does not have a notebook instance? Yeah, use lowercase name. Okay, still creating is fine. That's good, that's good. Still loading, that's great. Give it 5 minutes. We knew this step will take time, so we kept some time. Our experience shows that it takes about 45 minutes to get through this step. Okay, so Akshay Upal got it running. Carlos got it running. How many instances can you create? I don't know if there is an upper limit, but for now, just create one. Don't go crazy on it. It's a free account. Okay, let's get, is there anybody still loading? Please send a message. Okay, somebody's saying it's ready, but not seeing the Open Jupyter Notebook tab. Okay, a lot of people still loading.
Yeah, the instance is ready, but the Jupyter Notebook still needs to be, the actual module still needs to be spun up there.
Yeah, but they should see a Jupyter Notebook tab here, over here. Somebody says they cannot see it. I mean, I never had anything. Did you go to Notebook and do it? If you go to Google Compute Engine and do it, you won't see the Jupyter Lab. But if you go to Notebook and create an instance, you should always see a Jupyter Notebook, Jupyter Lab. Is there anybody offshore outside that is on the, sometimes people who are not in this domain can have problems. I had a colleague mention that to me once because Vertex is so new. But does anybody have a problem yet still? Or is it all, everybody's on board with Notebook? Okay,
Yeah,
still
just to
loading.
let you know, I also have a notebook instance in my Quick Lab project, and the circle is still spinning for me for a while. So probably just wait for a few more minutes, and you should see the Open Jupyter Lab button. Yeah.
Good to know. Thanks, Albin.
Yep.
Yeah, whatever you're experiencing, let us know, so we don't rush ahead and leave you behind.
I see some folks are using their own Google Cloud account. Please use the Quick Labs instead.
Yeah, if you use your own Google Cloud account, you're on your own. Yeah, it should say Open Jupyter Lab, correct. This one, you can see my screen. So once you're done, click Open Jupyter Lab, and a notebook instance will come up, and it will look like a blank notebook. And then you click the plus sign over here. That's the launcher, and choose the terminal. Okay. So once you open the notebook, click the plus on the top left and click the terminal. Okay. Elvin, do you have the instance done?
Yep, I can see the Open Jupyter Lab button now.
Great.
So mine is ready.
Anybody else do not have the Open Jupyter Lab button? Okay. So click the Open Jupyter Lab button, click the plus on the top left, and click terminal. And once you do that, a terminal window will show up like this. Actually, right. And whatever the name of your virtual machine that came in, that default name or whatever name you gave will be over here. It's a Jupyter at the name of the instance. Anybody do not have a terminal window? Okay, Natasha says her button is grayed out. Which button, Natasha? Is it the Open Jupyter Lab button? Huh. Does it still say loading? Is there a green check mark next to your instance? Because if it is stopped, you would have, no, this will be grayed out. Is there a green check mark? Oh, you need to start the instance. Yeah, her instance is stopped. For some reason, she stopped it. So check this and say start. Check that instance and click start. Okay, click this check and click start.
Yeah, another way, maybe just click the refresh button beside the start button, and
yeah, you can click this refresh and see if there is something that your screen is not up to date. Huh, she has a green tick. Okay, so.
Can you hear me?
Yeah.
Yeah, so it's, yeah, I've got the green tick and it says Open Jupyter Lab, like in gray, like the same as your third one. And then my start button is gray, like your one at the top.
Can, for us, can you let Natasha share her screen?
Let me see.
Can you share your screen, Natasha?
It's disabled as a participant, I think.
Oh, just give me 1 second. I'll enable it.
Okay, thanks. Oops. Lost start video.
You should be able to see your screen. Share your screen now.
Okay. Oh, it just said it asked me to turn on my video, but the participant screen sharing still not on. Oh, wait. No, sorry, it's just refreshing. Do you see it?
Okay, so yeah, I do see. This is weird. Can you hit the refresh button? Can you click the refresh? Okay,
Yeah.
do new instance. Click new instance. Click another new instance. Okay, go to TensorFlow Enterprise 2.1 without GPUs.
Okay, shall I change this to central again?
Yes, central. By the way,
that was all,
Natasha,
right?
that's TensorFlow 1.15.
I chose the correct.
Yeah, but
Cancel,
sometimes like it
cancel.
makes a mistake and you need to be careful. I
Yeah.
did the same mistake.
Correct. Cancel it.
Hang on. Okay,
No,
sorry. So I'm clicking new instance,
Yeah.
and then I'm in 2.1.
Yeah. See, that's
Oh,
the
I
one.
see.
No,
there were two.
not the
Okay,
top.
right, no,
That's
sorry,
the one.
got it.
Yeah. Correct.
They messed up in
Now
the
you
UI.
got 2 points.
Oh dear Lord! Right.
Yeah,
Okay.
we should
Let
we
me-
should give this feedback to our product team to fix that UI a little bit better. Yeah, I saw that problem myself.
Yeah. Although this one does look like it is a 2.1. I think. No.
It probably is. Yeah, it is a 2.1.
So if you
Let's
hung
try it
your
again.
if you hung your mouse cursor over the Open Jupyter Lab, the grid button, and does it give you a hint?
Yeah, it
Sorry,
says
can
you
you
should
say that again?
start the instance.
Yeah, it's weird because your instance is already running.
That's what the green tick means.
Yeah,
It says ready.
Let's drop that one and see how the new one looks. We can only debug so much.
Should I could press stop and then start maybe? Oops.
No, don't do anything. Just
Should I just wait for this to stop spinning?
Just wait for this one to stop spinning. Correct.
Did you say I might have a problem if I'm not in Canada? As I'm not.
Well, I had a colleague who had some problem in creating notebook instances from outside US, and these folks were from India. Is anybody from Asia on this call that had everything go through well? So you're the only one from outside US? Is there anybody from outside US? Anybody? I mean North America. Oh, somebody from South Africa worked fine. Somebody in Peru worked fine. From India worked fine. Okay, so it's
Shall I try and
nothing to do.
refresh it?
No, just wait.
Okay.
Just wait for that spinning to end and for the Jupyter Lab to show up. Okay, so what I would recommend is that all the GK stuff, you do it tonight after the lab. You have the instructions. Please make sure you have it ready for tomorrow morning. And we don't want to spend a lot of time right now going to the GKE. Yeah, somebody's saying United Nations of Machine Learning. Yeah, with a virtual setup, anybody can join. I don't even know. Oh, there you go.
Hey,
You're
all right.
Okay, you can stop sharing your screen.
Okay.
And I'd like to go back. Okay,
How do
that's
I
what I
stop?
said.
Oh, there we go. Thank you.
So, awesome, thank you. Natasha, you can mute your audio if you want.
Yeah.
Okay, so go to Jupyter Lab. And there you click this plus sign and click to terminal window. And a terminal window will pop up that will look like this. And now you need to copy this line and clone the repo we have created for you. And anybody who has done software engineering knows what git clone means. Okay, so once that is done, we'll go to the storage bucket. So for the storage bucket, I would recommend that you pin it. So you go down, and here is cloud storage, and pin it. And then it should show up over here. So Vertex AI, AI platform, Kubernetes engine, and cloud storage. These 4 items, I recommend you pin them. Okay, then just follow these steps here. Create the bucket. Okay, once you create the bucket, we'll stop here for today. Create the Kubernetes cluster and all of that. We can do it on your own time, okay?
Yeah, Chanchal, a very important point. So when you are creating the bucket, you should not create it for like a global bucket. You should create a US central one as well. So I can share my screen really quick to demonstrate how to create a bucket in that location. Yeah.
Yeah, we should. For some reason, Zoom is not working very well. They keep saying loading, and it takes forever for a screen share to show up. I guess they don't like Google folks. I'm kidding, of course. Yeah, let's stick to the topic of discussion.
Let me see if I can share my screen.
Yeah, I can see
you
your
guys
screen.
see my screen?
Yeah.
Okay, awesome. So yeah, I'm in my Big Lab project, and I shall go to the GCS bucket. So I just search for cloud storage. You can do the same, or you can find there's a tab in your sandwich button. So just to go to cloud storage.
Yeah, from the sandwich, choose cloud storage. And right here, let's go slow, Elvin. So he just created, click create bucket. Every step repeated 3 times. There are a lot of people on the call.
Exactly. So yeah, I'm showing right now is that you're looking at the main dashboard of cloud storage, and you should see a big button saying create a bucket. Just click that. Give the bucket name. So for me, I'll just name it my name with some like so today is June 14th. I'll say so. Make sure your bucket name is universally unique. So it means throughout the entire GCP, your bucket name should be unique. So don't yeah, don't name it very simple or general. Yeah, get a very special or unique name. And
so let's adopt a strategy. Your name, and then put today's date, and then choose a region. Under continue, click.
Yeah, so the first step is name your bucket. Once you come up with the perfect name you have, then click next. You will see choose where you store your data. So there's a multi-region, dual region, and region. So just choose a region and select the US central one here. So this the list problematic for me because you need to communicate your bucket with Vertex AI API. So if you choose a bucket as like multi-region or dual region, sometimes it will give me error. So I think the simplest way is just to make sure a bucket is in US Central 1. That solved a lot of problem for me. And keep clicking continue. I think for storage class, you can say standard, which is a default. For control access, use uniform, the default. You can use Google Managed Key as default as well. So then click create.
I think rest all is default, just the region.
Right. Just to give it a good name and also make sure the region is US Central 1.
Okay, so create a US Central 1 bucket only. For this, you should click create bucket, give a unique name. I suggest you put your name and today's date with the underscore in between, like Chanchal underscore June 14, 2021. Click continue right underneath the name, not at the bottom, and then choose the US Central 1 region. Then you say create.
Yeah, so you need to select a single region to select US Central 1, right? So multi-region means like you have data spread everywhere in multiple data centers.
So Vertex AI did not require any API enablement, right? It was already there, right?
Yeah, so once you click the enable Vertex AI API, you should be good.
I'm making those changes in this note so people.
Okay, let me try to delete this bucket, and I will just showcase how to create a bucket again. So to create a cloud storage bucket, go to storage, cloud storage, browser, just to give you the UI of the cloud storage dashboard, and create bucket. Give the name, so I just to say Helen Chu.
Unique name. It has to be globally unique, not locally unique.
Okay. And make sure data is in region, not multi-region, and US Central 1. Then you can just click create to build the bucket. So when you click browser, again, you should see your bucket here, listed here.
Okay, I added these in the notes. So for us, I'll update the PDF file and email it to you. And if you could please email it to the whole list. Awesome. So I think we are ready to start today's lab once everybody's on board with that. So anything beyond this, all the Kubeflow stuff or Kubernetes, please do them after the lab tonight so that we are ready tomorrow morning or whenever you have time before the lab begins. Our lab starts 10 a.m. Pacific time, which is 1 p.m. your time, Eastern time. Okay, anybody does not have the bucket set up? Yeah, let's not address the Kubernetes stuff right now. I'm not going to go into that. We'll keep half an hour tomorrow morning to see if there are any questions or anybody got stuck, and we can resolve them tomorrow. So anybody has an issue with bucket creation? So they have the notebook and the bucket. Yes, follow the instruction in the document, step by step. You should be able to set it up yourself. Otherwise, tomorrow morning, we'll take 30 minutes and go through the steps. If you're too nervous about doing it, don't worry. We'll do it tomorrow morning, 10 a.m. Okay? Awesome. Should we take a 10-minute break and start with Elvin's presentation? So we start at 1:30 p.m. our time, which is Pacific time, which is 3:30 p.m. Eastern time. Is that okay?
Yeah, we can take a 10 minutes break, and if you still have any problem with setting up the bucket or the notebook, just ping us. We'll be here.
Great. See you at 1:30 PT or 3:30 ET. Okay, so we are ready to start.
Cool, let's roll.
Great. So Elvin, you're ready then? Let's get started.
Awesome.
I'll go on mute.
Okay. Yeah. So if everybody's ready, so we can start. And today I'm gonna talk about using Vertex AI training and also to train a custom XGBoost model on GCP Vertex AI. Once you have finished the training, also go through how do you import your model artifacts into Vertex AI model library, create an endpoint, deploy the model on Vertex AI, and also do example online prediction, use the model you just trained. So the first step, probably you just go back to your notebook you just created. For me, I'm sharing my screen, I think. Just to go back to Vertex AI notebooks, click the Open Jupyter Lab. It will create a new tab for you. If you haven't done that yet, just do git clone. HTTPS github.com Alvin Zhu cu vapit.git. So that's the Git repo you want to use for today's demo. Once you run this code, it will create a new folder for you. It's called vapit. And inside the vapit folder, you will see multiple subfolders. Today, I want to use one is AI platform XGBoost. Click AI platform XGBoost. You will see one Jupyter notebook file down below called XGBoost Vertex. That's the one I want to demonstrate for you today. And also, you want to also click the XGBoost setup. That's the setup file. I will also go through really quick. Yeah, so to mention again, just do a git clone on your Jupyter notebook, and you will find a new folder, Vapit, and in the Vapit, you will see two files, XGBoost setup, XGBoost Vertex, and that's the two files we want to cover today. Okay? Cool. So basically, what is Vertex AI? So Vertex AI is, you can think of it as a center for all your artificial intelligence jobs, right? So even if you want to build a model yourself, or you want to train a model using AutoMLs, or you want to upload a model for prediction, everything happens in the realm of Vertex AI. So if you know GCP, many years ago, there's a product called CMLE, which means Cloud Machine Learning Engine. That CMLE concept is just to provide you the proper VM for your training and prediction jobs. So you have CMLE training, CMLE prediction. And a few years later, we just deprecated CMLE name, but the concept is still the same. So we call it AI platform training, AI platform prediction. But as many of you have already seen in the Google I/O last month, we have this new name for the unified cloud AI platform. So we do not call it unified cloud AI platform anymore. We call it Vertex AI. So that's a Vertex AI. So Vertex AI combines the cloud prediction, cloud training, also the out-of-out portion of the machine learning products. So you have the choice of doing, for example, image classification, image object detections, natural language classifications, tabular data regression or classification, a lot of things using just AutoML models as well. So Vertex AI it's just to combine all these models together, so you can just upload one data set and use different either custom models or AML models, whatever you choose, to train your data and compare the performance and deploy the model to the endpoint. Today, we're going to showcase an example of building your own XGBoost model. Once you have built the model, you train the model on Vertex AI virtual machines, which is a much easier way to scale and distribute your training rather than train locally on your laptop. And then once you have done training, you deploy the model onto Vertex AI to the endpoint, and you can do online predictions using the models. First, let's look at the setup file. In the setup file, we have the first cell saying bash cd home, just the cd into the Vertex AI folder. So here I still have the old folder name, so probably I should change it to Vepet. And do Python 3 pip install. So that install all the requirements files you need. And once you have installed this, you don't have to run this cell, to be honest. So this is just showcase how do I build all the files within the folder. So once you have installed all the requirements, in the next file, I create a new file named setup.py. Everybody should know setup.py, just a configuration file for you to build your Python packages. And in this file, we just list all the required dependency packages and give the package name and several user input configurations. Also, we write a new file called trainer in the trainer folder, initiate, just to indicate this folder trainer is a Python package. And here is a major part. So in the trainer folder, we also have a train.py file. So this train.py file is the actual machine learning happening here. So we just use the data we have in the GCS and input into a XGBoost, fit the model, and save the model again back to a GCS path. That's a very simple XGBoost model. And the data we used, for example, as a demonstration today is the Freddie Mac mortgage data, which is a tabular data. And here is the example of a very simple train.py file, which consumes the tabular data and output a classification result. So after that, we also have train underscore HPT. So HPT stands for hyperparameter tuning. So in many cases, there's a bunch of hyperparameters. Like in XGBoost, I can think some hyperparameters like number of estimators, the max depth of your trees, and also the booster you choose. right? So you can random search those estimators by running multiple experiments, but usually it's more efficient and more faster to find the best combination of hyperparameters using our hyperparameter tuning job that's provided by Vertex AI. So hyperparameter tuning job is run your machine learning training and apply your model on some kind of a validation data, compute the metrics, and based on the metrics, it choose the next combination of your hyperparameter. If you use Gaussian optimization to optimize your hyperparameter choices and make sure you get better hyperparameters throughout different experiments more quickly. So to use hyperparameter tuning, you need to change some of the code of your train.py file. So that's why we have two files. One is called train.py. The other one is called train_hpt.py. These two pieces of files are very similar to each other. And the only difference here is once you have trained a model, you need to, first of all, you need to evaluate the model performance. So here we have one function called test_xgboost and compute a score based on the evaluation data, or say validation data. And the second step, once you have the evaluation, you need to report your metric to the Vertex AI. So how do you report the metric to Vertex AI? So Vertex AI knows what's the metric of your current hyperparameter tuning job and try to find the next best possible hyperparameter for you, right? So how do you report the metric? It's very simple. You just import the hypertune package and do these two lines of code. So once you get a score, you give a name tag of your metric. Here we call it IOC AOC, which means area under curve IOC. And also the metric value is the score you just computed. So very simple. You just change some of the code here with your original train.py, and you have a file ready for hyperparameter tuning. Other than that, we have other configurations for old AI platform training, but I should not cover it today. You can use this configuration for training on AI platform, but for Vertex AI, we have different format of the configure YAML, but also we can configure those configurations within when we are calling the Vertex AI API, which I will demonstrate later. So once you have the XGBoost set up and you run those cells, you will creating the files with your trainer folder. You will see those files available to you. But here, because you download just a git clone from your repo, I think everybody should already have those py files, and they should be good to go. Another thing before we run Vertex AI is we need to build the Python package and upload the Python package to a GCS bucket, which can be accessed from the Vertex AI API. I will cover that just a few seconds later. So let's go back to XGBoost Vertex notebook. So just by looking at this notebook, the first step here is to install some of the packages we need. Because Vertex AI is new, it's just being announced last month in Google I/O. Some of the packages are not up to date or available within our Jupyter notebook once we create it. So we need to do this Python pip install thing to have the compatible packages available for us. So you can go ahead and comment those lines and do a pip install for all the packages out here. So for me, I'll just run those. Okay, so here it asks me to opt in something. So Probably I need to give a quiet flag here.
Elvin, it should be quiet, Q-U-I-E-T.
Is that correct?
No, Q-U-I-E-T.
Sorry about that.
Yeah, yeah. Typo.
Okay, except one error. What's the error? You cannot perform this action because disabled for this installation. Following command actually the same.
I got the same error, but it didn't matter.
Oh, okay. Yeah. So if you run these commands, it will install the package for you to run this demonstration. Be sure you also add this flag quiet. So once you have run the installation, I think the suggestion is to restart kernel to make sure all the packages are reflected within your current session of the kernel. So to restart kernel, is just to go click the kernel in the menu and click restart kernel. Okay, once we have restart kernel, I think all the packages to use Vertex AI are ready. So we just import those packages as a first step, and then to be carefully, we need to specify those user input here. So first of all, the project name. Make sure this one is exactly what's the project you are running your notebook on, right? So if you go to the next cell, I have a code snippet using gcloud to return your GCP project name. You can also do exactly the same if you go back to the console and copy the ID here. That should be equivalent. So we need to change the project name to the project we have been working on. And user should be your username. So my name is Alvin Zhu. Just a change to your username, please. And the bucket name should be exactly the bucket you just created in the GCS. Right. So let me go back to the GCS bucket, cloud storage, browser. I have this bucket name, Alvin Zhu, June 14th, 2021. I just replaced the bucket name with the bucket I have. The folder name can be any name you come up with. Here I just named XGB train job. You can name whatever you want. It will be the folder inside of the bucket above. And time zone should be either US Pacific or the time zone you are located in. So yeah, just to configure those user input here, please. And since we are still waiting for some people to finish the package installation, I'll just pause a little bit here. User can be whatever. You can use your own name, or you can use temporary username. The important thing is the project name has to be the GCP project. I have a code snippet underneath gcloud configure list, format blah, 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 blah. So it will return the project name for you. Another way to get the project name is to click the project name here and copy the ID in the console. Yeah, two ways to get the project name. And the bucket name also important. Make sure it's the exact same bucket that you created. Yeah, username, it can be arbitrary. That's right. To answer Jono's question, project name, you just run the cell below, I think the G-Cloud configure list cell, and it will return the current project name for you. If you've been installing the package for a long time, can you copy paste your return values maybe in the chat? So one thing is you want to add this quiet flag because that's for you if you want to opt in some survey and you cannot type yes or no inside the Jupyter notebook, right? So probably give it a quiet flag to suppress that. Just running a long time. Yeah, so for Jupyter notebooks, the thing is, if you give it exclamation mark, it just means the following command is not a Python command, it's a bash command. So it is the equivalent to run this line of command inside a Linux shell, right? So if you find difficulties running in Jupyter Notebook, you can also copy paste, except the first exclamation sign is to copy paste this one by one. And you can also do installation within a Linux shell. Right, so there's two pieces. So one is a project ID. You just run this cell to get the project ID here, quick lab GCP 03 blah blah blah. And the other piece is the bucket name. This bucket name should be exactly as the bucket you just created. You just go back to cloud storage browser, you will see the bucket name there. Just to go back to GCP console and cloud storage, you should see that bucket name. Yeah, if something doesn't work, a good practice is just to click restart kernel and run again. Especially after you install a new Python package, the Jupyter Notebook may not pick it up, so you have to restart the kernel to use the newest, latest package. Folder name, you can leave it as you can come up with any folder name you want. It's just a subfolder name under the bucket you created. So for XGBoost, I usually named XGBoost XGB train job. I have another example using TensorFlow. I just named the folder name TF train job. So it's just for separate different model training jobs. So you can leave as default if you want. Yeah, the project ID, you just run the second cell where you see a G-Cloud configure list minus my format. That's where just to run this cell, you will get the project ID. Another way to get project ID is go back to GCP UI for the console, click here on top, you will see the project ID listed here. So I see Andy have an error message. Could not install packages due to OS error. No such file directory. Conda Python 3.3 set package Google Cloud Storage. Right, make sure your Python packages are all up to date. Once you have run the first cell, it will install all the available package for you. And make sure this cell finished. And you can wait for the cell to be finished and then click kernel, restart kernel, and then import packages. The time zone should be, can be whatever time zone you want. So actually, the way we use the time zone is just because each job has to have a unique name. We use this datetime and PyTZ to append a timestamp after your job name, right? So you can keep it as US Pacific if you want. It would just give the time at the Pacific location, but it doesn't really matter. So the thing matters is the region has to be US Central 1. So don't change this one. I should remove this part. Don't change this one. Just use region US Central 1 because that's the bucket you created, the location of the bucket. So the only thing you need to change is the project name and the bucket name. These two things, definitely change those. User, feel free to change. Folder name, feel free to change. And time zone or region, I suggest that don't change those. Right, another clue is look at this little circle on the upper right hand. If the circle is black, it means it's still running. If the circle is white, as what I've shown now, because it means the notebook is in idle. Now no program is running. Yeah, I think the configuration and setup takes a while, but after this, everything should be much smoother. So feel free to slow down and ask questions. Okay, are you able to install all the packages and configure all the user input here? Okay, awesome. So I think I'll just move forward and watch the chat. If any problems come up, I can go back and try to solve those. So the next step is to create the bucket I show here. But I think every one of you has already created the bucket, so you don't need to run this part. So the thing is, if you run it, because the bucket is already created, it will give you an error message. Let me run this first. So if you already created the bucket, you will get a similar error message as I have. So it will say the cloud storage bucket named this has already existed, right? So if you haven't created the bucket, it will create the bucket in US Central 1 location for you. But if you have already go ahead and created the bucket in the UI, you can ignore this step. Okay, so once you have created the bucket, the second step is to package up your Python code into a tarball and upload the tarball into a GCS path within your bucket. So here is the code to do that. So first of all, you need to uncomment this cell. I think originally this cell was commented, so just remove the comment, uncomment the entire cell, and it will run the Python build for you and package up the Python code and upload the tarball into the designated GCS path. For me, it runs no problem. You can see the Python is building the tarball for me, and I end up creating a new folder called distribution, dist. Within the dist folder, I have trainer /0.1 tar.gz. And this file, this tarball, has already been copy pasted to the GCS path I gave it to it. So if you go back to the bucket you just created, for me, it's Alvin Jewel 06/14/2021. If I click into this bucket, I can see there's a table located in the GCS path ready for me to use. So if you see an error message says no module named build, I think that's probably you haven't installed the Python build correctly. So try to restart the kernel, run the last line of Python pip install build again. Once the build is installed on your machine, do kernel restart kernel again and go back to build your Python package. Cool. Yeah, so if you say an error message saying no module named build, probably you haven't installed the build package there. Just try to make sure you have the build package installed. Yeah, project name, everybody should have different project name. Go back to the console, click the project name button on top, in the top banner, and you will see the project ID listed here. That will be your project name. For me, it's Quick Labs GCP 03940 blah, blah, blah. For you, probably same pattern. You will see Quick Lab GCP, some different numbers. For those who doesn't have a who have an error message of a wrong number of arguments of CP command, the copy command asks for 2 arguments, I think. So try to check your package URIs has some value in it. So for me, package URIs should be this one, right? So if its package URI is empty, it probably give you this error message. So try to make sure your package URIs has a value. It should be a GCS path to your designated package location. So newly created trainer /0.1 turbo is created by Python build. So you see this line of code, Python 3-m build. It actually reads the setup files I just introduced. So you will see a setup.py file, and you will also see the trainer Python module, which contains the init file and also 2 Python files. So it will wrap up this folder, install all the dependency packages, and wrap up everything into this turbo. So once you run this line of code, Python 3-m build, it will build this turbo for you. Then the next line of code is just to copy the turbo you just built from local to GCS. So Arma, you have pasted the error message, could not install package due to OS error. Is this an error when you are installing Python packages in the first cell? Right, so you can see the setup contains all the information you need for build Python packages. So for example, you have write some Python code and want to distribute it to PyPy so other people can download your package. you're gonna use the same thing. So you're gonna use Python build to wrap up your package and upload to PyPy server to distribute it to other people. So same here. So if we want to use the trainer train.py file, we also need to wrap these things up into a tarball. So the Vertex AI virtual machine can read the tarball and your training code from there. Very interesting. So Jono has a question about the error message, which I haven't seen. But Andy suggests if you run all the code in setup file, could fix that. Very interesting. Because I'm also using a QuickLab project right now, so I don't have any, so the dependency or the package that I have should be exactly the same as everybody else. So I haven't run the XGBoost setup. Yeah, so another way go around it is just copy paste the code with the first exclamation mark. Just copy Python 3-m and so on into your Linux console. And you can also install packages from there. These are all bash scripts. Yeah, try to restart kernel. Sometimes they do magic for you. Just restart kernel and rerun the first cell. Make sure you have this flag / quiet. Rerun this cell and then restart the kernel again. Okay, so what do we have done here? So we have imported packages, we have installed the package and imported packages. We have configured some of the user configurations here, especially the project name, also the bucket name you just created. You have created a bucket either using UI or the code I've shown here. You also wrap the Python code into a Python package turbo and upload the turbo into the GCS bus. So from there, we are ready to run some of the machine learning pipeline code here. So first of all, you want to configure the data input route for Freddie Mac tabular data for the training. So here the input data is located in this GCS path. So don't change anything here. It's a public GCS bucket containing the original training data. It's called GS2D asset dataset mortgage structure.csv. So this CSV file contains everything we need to use as data for today. And the target column is a column name for the classification labels. So if I can show you here, just copy paste this Google Sheet here. Sorry about that. Yeah, I'm just trying to figure out how do I share another window here. Okay, so I'm sharing a Google Sheet containing the original CSV data. So I just download CSV to my local machine, then upload the CSV to a Google Sheet, and you have a clear view of the columns and the values inside those columns. So we can see this is our training data. The first column is called loan sequence, which is a unique ID for each loan. This is not very useful for machine learning purposes. So in the actual pre-processing, we're gonna discard this column and use the rest of those. And for the rest of the columns, we see credit score, if the user is first-time homeowner, what's this, metropolitan division, whatever it is, and mortgage insurance percentage, and so on. So one column is called a target. So if I can find that. So here, this column is called target. So in this column, there's integer number contains either 0, 1, 2, 3. So there's 4 different classes to be classified for those mortgage appliers. So today's our goal is to use a XGBoost model to classify based on the columns values here in this CSV file into different categories of 0, 1, 2, 3. Okay, just to give you a very brief view of the training data, what does it look like? Then let's go back to the actual code. Okay, so I think I'm sharing the correct window here now. So I go back to the Jupyter notebook, and after defining the input data path and the target column, the first thing we want to do is do a data preprocessing. So there are 5 steps within this function. Dropping unique ID column, which is the first column, sequence number I mentioned in the spreadsheet. Convert categorical into one-hot encodings. So we can see some of the columns does not contain or integer or float number, but a categorical string. So XGBoost model cannot use those strings directly. We need to convert the categorical feature into one-hot encodings. Okay, sorry. So some people mentioned I'm sharing the wrong window here. Sorry about that. It's really hard to figure out which one is which, just by looking at those. Should I show this one? Is this correct? XGBoost Vertex? Okay, awesome. Cool. We can keep going. And yeah, so this pre-processing comprised of 5 steps. Dropping unique ID column, converting categorical features into one-hot encodings, and also counts the number of unique classes. As I mentioned, there are 4 unique classes, 0, 1, 2, 3. And also we want to split the train and test dataset just by random splitting them into 80% training and 20% testing. And save the processed data into the GCS path. Because we already configured the user input in the previous cells, so now we can use those configurations within this Python script. So just run this cell. Okay, I'll run this one. Okay, just run this cell, and you will see some info saying the pre-processing is running. Dividing the entire CSV file into 93,639 samples of training and 10,405 samples of testing. You can also see the dimension there for the feature is 149. The label just have 1 dimension. So for XGBoost model, we don't need to one-hot encoding the label column. So that's why the Y shape of the label column is 1. If we still have time, we can go through the TensorFlow model where we require one-hot encodings there. You will see, because we have 4 different classes, this shape will be 4. The Y shape will be 4. So we finished, and we copy paste the training and testing data into different files within the bucket you just created, and you will use those data for training of your XGBoost model. So does anyone have problem running this cell? Or we are all good? Awesome. I see a bunch of yes. Okay, let's move on. So training with Google Vertex AI, right? So as a data scientist or machine learning experts, the thing you want to do most is build exciting models using state-of-the-art architectures and get awesome performance and accuracies from your models, right? But sometimes most of us find out that a lot of time, or say the majority of time we spend on, is trying to set up the machine learning pipeline for data ingestions, post-processing, figure out bugs, trying to set up the correct environment, like for distributed training or GPUs, things like that, right? So we spend a lot of time on those ML ops jobs instead of the actual data science or machine learning core jobs. So that's where the Google Vertex AI come in. The Google products really want you, the data science experts, to focus on the cool part of the machine learning, and it will take care of the other part and give you a very cost-effective way to train your models. So think about if you want to train a large model on your local machine, that's probably going to take days to actually see an initial result for just a one iteration. You're probably going to find a lot of bugs, different setups are not working, and you go back, change the model architecture, and it takes another days, right? So you think about, oh, okay, this is too slow. I need to add a GPU to it to make things faster. So you go ahead and buy a GPU and install, and you have to install CUDA, all the drivers, things like that. It's very tedious, and it never do the job correctly. And then you figure out, okay, I can use the Jupyter notebook on GCP, right? So if you set up a Jupyter notebook on your GCP, it's much faster. It's like you also have the choice of Colab, similar stuff. And you can configure GPU there, and everything like the driver and everything else, the TensorFlow packages are taken care of for you. And you should be able to focus on training your model, right? But sometimes the one single VM is not powerful enough to handle your powerful model training jobs, right? So you want to distributed training, you want to use GPU accelerators, you want to even use TPUs. What do you want? How do you do that with a single notebook virtual machine, right? So you want to move this heavy lifting job from your notebook VM onto a dedicated VM for model training. So that's where the Vertex AI training comes in. So the Vertex AI training has a fully managed VM for your model training jobs. You just write your train.py code and upload the code into Vertex AI. And the GCP will find the correct resource based on your configuration for you and do it very cost effectively and to train your model very fast, very quickly. And you will iterate on your model much faster than your training model on your local machine. And more than that, so Vertex AI also combines the power of AutoML models. So you may not want to write your own TensorFlow code or XGBoost code. You can just use a out-of-box model AutoML. It will do a hyperparameter tuning, model architecture search, all the state-of-the-art technologies automatically for you, and will train a model very accurate and with high performance for you automatically without you designing anything. So that's another choice of Vertex AI. And then you also have the Vertex AI prediction, right? So once your model is trained, you can deploy a model to endpoint, and you can configure the endpoint to use different configuration of the VMs. So for example, you can configure multiple VMs based on your query per second or your desired latencies for your predictions. And you can also add accelerators like GPUs to your prediction VMs. So it's much easier to deploy the model into an endpoint of Vertex AI in the production environment. Imagine yourself as a company and you really want to use machine learning to solve some of the questions you have or a business value, adding business values to your organization. Vertex AI is much easier to manage and much cost effective. All these things like training and prediction, you are just paying for whatever you use, right? So training, if you want to train a model for 8 node hours on Vertex AI virtual machines, you just pay for the 8 node hours. You are not paying for anything else. So the good thing about Vertex AI is everything is managed. So it unfortunately doesn't support on-premise deployment. But we also have the open source counterpart of this stuff, right? So probably you guys know Kubeflow pipelines, things like that, that will handle on-premise deployment instead of using GCP products there. So, okay, so I've speak a lot, but let's move on to actually training a model using Vertex AI. So first of all, we want to configure the job name and the job DIR. So the job name is a display name to differentiate your current job from other experiments. So here I just use XGB train as a prefix indicating this XGB training job, and also add a username to indicate that's me using the Vertex AI, and also the timestamp to differentiate different parallel jobs. You can use different format, but you don't have to change anything here. And the job DIR is a cloud storage path to store all the model artifacts and also intermediate results for your model training jobs. So for example, the XGB model, once you have finished training, you probably end up with a model artifacts. It's a XGB model file in your local folder, right? But here, because you're using Vertex AI, you need to save the XG model, XGBoost model into the job DIR. So here for initial run, we just use some random hyperparameters. So we just say a booster of the XGBoost model should be GB3. Max depth, just give a very small number 2. Number of estimators 10. Just some random hyperparameters here. And to test your train.py file works, you can that's no module named hypertrain. Okay, so I have error say no module named hypertrain. Does anybody have the same error as me? So I see some questions. So what is open source version for on-premise? That's open source is Kubeflow pipeline. So because Vertex AI contains a lot of things, right? So Vertex AI contains the training VM, the prediction VM, also the pipeline managing. So the pipeline part can be replaced by open source Kubeflow pipeline. But there's no really replacement of the training VM or the prediction VMs. If you want to use those things on premise, I suggest TensorFlow serving for prediction. Okay, somebody got the no module hyperparameter tuning. Somebody didn't. So I think I need to figure out how to fix that issue. So one way of doing it is just to run this Python 3 pip install requirements. Yeah, because like Quick Lab environment and my original GCP environment always different. Sometimes it's kind of easy to missing some of the package we need to use. So here, I think the case is hyperparameter tuning package. Let's see if that fixes it. Okay, cool. So let me copy paste the code I just run here. Yeah, try to run this code in your Linux shell, and it should fix the missing package problem, I think. You can also run it in the notebook, like what I showed here. You can get some of the warning, but it can be ignored. Yeah, sorry about that, guys. It's a live demo always like this. So if you install your packages correctly, especially your hyperparameter tuning package correctly, you should see the result here. Say, copying file, model BST, operation completed. That means you have successfully trained your XGBoost model and saved it to your local directory. Yeah, so you should get some warnings, but you can ignore that. Go back and try to run this training on local cell to see if you can successfully train an XGBoost in your local VM. By local, I mean your notebook VM. So till now, we haven't used any Vertex AI yet, right? Everything's just a standard data preprocessing and training XGBoost on local machine. Just to check everything runs for us. So I also get some warnings when running those installations. So don't be scared by those warnings. The result of the local run should be a model BST file in your folder. So if you check your folder here, you should see model.bst file. Awesome. The folder structure, you can click the folder icon here. It will just toggle between showing the folder structure or hide it. The result will be a model.bst file in your local folder. Yeah, that's local to instance. That's the folder structure of your notebook VM. Yeah, so everybody has installed the hyperparameter tuning package and successfully run a train.py file. Yeah, great question. So why do we want to run a Vertex if that takes so little time to train? So to be noticed, this is a super simple XGBoost model, which takes no time to train, but usually your real machine learning job takes a long time to train. So you are looking at a much larger training data set running on a much more complex model architecture. So in those cases, if you want to do experiment to change, for example, hyperparameters or change model architectures, you are also looking for multiple iterations of running, right? So usually the major time spent by data scientists is just waiting for the model to be trained. That's why we want to use Vertex, where you can use a powerful virtual machine with GPUs or TPUs, and also distributed training, like multiple machines, and to save your time. And also you only pay for those machines when it is running your training job. Once the training job is done, those machines will go away and you will not pay for those. If you're using a notebook, for example, you can configure a very powerful Jupyter Notebook virtual machine with GPUs, a lot of memories, large CPUs, and disk. But the thing is, you probably need to remember to stop your VM instance once you have finished the training and start your instance once you want to start your training, right? So that may require you to stop and start your VM multiple times throughout the entire process. And not only that, it's much harder to scale your training. Like, for example, if you want to use a larger machine or you want to use multiple machines, it's harder to migrate your code to other machines. So Vertex AI make everything much simpler. And also Vertex AI has built-in pipelines, so you have the opportunity to deploy your Kubeflow or TFX pipeline directly onto Vertex AI to orchestrate the entire pipeline from ingestion, preprocessing, model training to model validation and pushing the model to deployment. Right. Okay, let's move on. So once we have trained the model on the local, we are pretty confident that this XGBoost model can be trained with no problem. Let's see if we can train this XGBoost model on Vertex AI. So to configure this, first of all, we need to have a client to Vertex AI in Python SDK. So you don't need to change anything here. So first of all, you need to configure the base Docker image you want to use. So make sure your base Docker image contains the Python package of Vertex AI. So here I just choose US Docker Vertex AI Training TF-CPU 2.2. This also is named TF-CPU. It also contains the XGBoost packages within this image. So we are good. And the Python module means when you are wrapping your Python code into your tarball and upload it into GCS, that's your Python module, and which is the access point, or say which is the Python file you want to run, right? So here we just configure it to be trainer.train, which means the folder structure of trainer, folder, and train.py file. API endpoint, this one you don't need to change it either. because Vertex AI has like multiple endpoints, we just choose US Central 1 as our dedicated endpoint for the training. Where I can find the value of executor image URI, that's a great question. So if you go to Vertex AI document, I think in those documents, there's a page indicating all the available image URI you can use for your training. So these are called pre-built Docker images. You can also build your own Docker images to include your own Python code in there, Python packages in there, and upload it to a GCR. And you can call your custom built Docker image for your Vertex AI as well. So here I just use a pre-built available to us without any customization. Okay, so the machine type is the machine type of your Vertex AI training. So let's see if I see other questions. So no, so actually the training is just a charge based on your machine type and your accelerators, right? So here we just use N1 standard 4, which means you have V4 CPU and certain type of memories. I think you got 12 gigabytes of memory or 16, I don't remember. You can check the doc. And you can have multiple machines. You can have GPU accelerators. You can even have TPUs. So different configuration will cost you differently. And you multiply your unit price of your machine type by the number of node hours you want to train your model on. And that's your final price. So the image here doesn't give you a different price. So you can use whatever image you want. So you have TensorFlow 2.2, you have TensorFlow 2.3, 2.4, and you also have 2.2 with GPUs, drivers installed on, things like that. So once we have configured those numbers, we construct the client using this line of code, AI platform GAPIC job service client, passing in all the client options in there. And for custom job, because custom job means we are building our own XGBoost model here. And we upload this model to a GCS path with train.py file. On Vertex AI, you can also incur a AutoML models, which is fully automatic. So for custom job, you also have to customize your display job, display name, your worker pool specs, for example, machine types. If you have accelerators like GPUs, you also configure that here within machine spec. And you also give some of the Python packages information here, right? So the base image you want to use for the Docker is this base image I just configured with executor image URI. The package URI is a GCS path for the tarball. So go back to cloud storage, trainer XGBoost, trainer. So if you go back to your GCS UI, you can see the GCS URI here, GCS Alvin trainer XGBoost trainer.how. This will be your package URIs, right? So that's exactly the same as what we have uploaded here in the previous cells. So remember when you are building the package and copy the distribute folder into the GCS path, that's exactly the same path. And Python module, again, that's the trainer.train. And what's the arguments you want to pass to your Python module, right? So go back to your local run. When you are running Python 3 trainer train.py, you have passed some of the user arguments to your trainer.py file. And you need to pass the same user arguments when you are using Vertex training. So again, you configure the job dir, train feature, number classes, etc. Once that has been done, you can just create your custom job and start training. It will give you a response saying the custom job is running. And the last number after the custom jobs, that this number is your job ID. It will provide you some information or say the configuration of your Vertex AI training. And the state is job state pending, which means the job is running and you should wait for it to be finished. Okay, so to have a better view, let's go back to Vertex AI training. You can click Vertex AI and training. You should see a list of different trainings. Click custom jobs. So under Vertex AI training, custom jobs, you will see the Vertex AI training job you just created with your XGBoost model. Click into it, you will see a bunch of informations like the job ID, what time does the jobs created, your machine type, how many machines you used, what's the base image container image, I mean, and also what's your arguments to your train.py file. Yeah, if you have difficult finding these custom jobs, you should go to Vertex AI training and remember to click this tab, custom job. Yeah, usually if you enable the Vertex API at the beginning of the project, you don't have to enable the API again. But if you don't, just enable the API here right now, and you should rerun the cell, and it should upload your job to Vertex AI. So one thing to check your job is running, just to run this cell, and it will give you a response. And will also show the state of the job, should say job state pending. That means your job is already uploaded to Vertex AI and to be run. So my job is running, and I can also click view logs to actually go into the virtual machine who is running my job and see all the logs there. So right now the job is to be provisioned. So it takes a while for the GCP to find the resource and spin up the virtual machine for me. So usually this is the overhead latencies for running the job on Vertex AI. So probably we should wait for a few minutes to see the job actually running. This latency is large when you are running an XGBoost model this small, but consider you are running a super large TensorFlow model with millions of input data. This overhead latency should be not so significant. Okay, as we are waiting for the Vertex AI job to finish, we can go ahead and look at the hyperparameter tuning part. So the hyperparameter tuning is like another Vertex AI training job. The difference is just it automatically trying to find the best combination of hyperparameters and run multiple jobs, can run it in parallel or like run in sequence. And after several running, it will give you the best combination of hyperparameters for you to use to train your model. So very similar. Again, you just define your job name and job dir as what we have done for Vortex training job. Here I just give a suffix HPT to mention this is gonna be a hyperparameter tuning job instead of an ordinary training job. And again, we just use TFCPU22 as our base image. But differently, we're going to configure this Python module to be trainer.trainHPT. So if you look at the folder here, we have two different files. That's what we generate when we are writing the XGBoost setup file. So one train.py is for ordinary training. TrainHPT is for hyperparameter tuning. So here we just use TrainHPT here. Everything else will be the same. API endpoint, we still use US Central 1. Machine type, we use a very standard N1 standard 4. And yeah, just to create another client, saying client options equals to API endpoint, create the client. Here, to be noticed, the hyperparameter tuning job needs some more configurations for you to tell the Vortex AI which hyperparameter you want to tune and what's the range of the hyperparameters are allowed, right? So first of all, you have to configure the metric you want to optimize. So Vortex AI knows if running is good or bad. So here we want to optimize the AUC of ROC, the area under the curve of the ROC curve. And the goal is to maximize instead of minimize. And here are a list of the hyperparameters we want to tune. So the first hyperparameter is max steps. We just give the parameter ID as max steps to be the same as your train hpt.py input. And you also tell this is going to be an integer instead of a float double. And you can configure what the minimum number you want to use and maximum number. So here I just use 2 and 20. Second hyperparameter I want to tune is a number of estimators. So similarly, it's integer with some minimum value and maximum value. Okay, so I found an error here. So booster should be booster, and this should be booster, right? So I code batch size doesn't matter because the booster here has to be aligned with the hyperparameter tuning input. Yeah, so here for this example, I'm not using the configure files. You can also using the configure files that will be doing the same thing as what we have done here. And so the configure file here for my example is kind of like deprecated. That's configuration file for the old AI platforms, which does a similar thing as Vortex AI. But I think Vortex AI, they have changed some of the syntax, so it's not valid right now. So this is another way to configure your hyperparameter tuning job. So you can still use configuration file, just a different syntax. So anyway, so we have this 3 hyperparameters we want to tune. So the third one is a categorical hyperparameter. So we have to choose between those 3 different choices, options, GB tree, GB linear, or dart. Once we have configured that, everything else is pretty similar. So we still specify the worker pool specifications, give some of the arguments. So those arguments are not hyperparameter tuned, right? So that will stay the same for different runs. And the tuned hyperparameters will be listed here. And we start the job, and it will create a hyperparameter tuning job for us. So similarly, if we go back to Vertex AI console UI, click training, you can see our custom job is still running, but click hyperparameter tuning jobs, you can see there's a new tuning jobs has been created, and it is running. Oh, another thing to be noticed is like we can configure how many trials we want totally. So here is the max trial count, which we configure at 4, and parallel trial count is 2. So this means we run 2 parallel runs at the same time, and after running totally 4 trials, we just stop the hyperparameter tuning. So this is a very small number, but usually when you are tuning a large model, you want to have max trial count about like 20 or even more. And parallel trial count is based on your choice. So if you have like a very small parallel trial count, it will have a longer tuning time, but the final result probably gonna be better because every run, every trial has the information of the previous runs. If you have high parallelization, you may run 5 trials at the same time, but they don't have the information of previous runs, so they cannot take advantage of those. We don't have seen a timeout options for each trial. I think we do, but I have to go back to check the docs. So I think we have this like early stopping feature. But another thing is you can manually stop the hyperparameter tuning job using a Python SDK or API calls to force it to stop. That's another option. Yeah, good question from Jen. So if we want to run hyperparameter tuning job for another metric, there's several things you have to change. First of all, remember you are writing this train hpt.py. You are actually reporting the metrics to Vertex AI. So here we are reporting RLC AOC. So for example, if you want to use F1 score or accuracies, you have to calculate those with a different function here and report it as accuracy or F1 score. And back into the configuration, then you change this AUC, ROC into the metric you want to use. So there's 2 places you need to change if you want to use a different metric for hypertuning. Okay, so once we start the hyperparameter tuning, we can check the status of the long-running option. So if you run the cell below, you will see it actually automatically check the current status of a hyperparameter tuning job. That's some of the specifications they have tried. And so for trial 1, the machine decided to use max depth equals 11, estimators equals 105, and GB tree for booster. And the status of the hyperparameter tuning job is still running. So you can also see the information from the console UI. So because we configure the parallel run is to be 2, so we can see 2 trials are running at the same time. They just randomly pick a combination of hyperparameters. And the RLC AUC will be reported once these 2 trials are finished. So Andy's question, if we change train HPT or train PY, does Vertex AI keep the old version? No. So go back to the training configuration. So we have this package URIs, right? So this package URIs indicate where your Python packages containing all the training code located in. So if you have a new version of the code and you re-upload it to the same package location, it will use the new version of your code. You can, the good practice is to keep track of every version of your training code. So probably you're gonna upload your new version to a different location. Then you need to change this package URIs for the Vertex AI to point to the newest version of your train.py. Okay, I think this training job and the hyperparameter tuning job gonna take a while, and it's a good time for us to go back and answer some of the questions. So I think JS has problem enabling Vertex AI API 2 times already. I'm not sure why is that. So it's just a clicking of a button. Super strange. Do you have any error messages?
Elvin, if you want, we can have them share the screen.
Yeah, please, if you want to share your screen, please go ahead and I can help you debug that.
I think somebody has to enable their screen sharing option.
Okay, should we ask?
For us, is for us still there? Can you share the screen, or if you try?
Okay, so permission denied to an enable service. AI platform help token.
Did you make the bucket in the US Central?
Yeah, I think there's 2 different questions. So JS is AI platform API, and Fion is the service account accessibility to JS bucket. So JS, do you mind if you go back to your Vertex AI console and click the dashboard to see if you still have the button saying enable API to you? Just to click that button. Yeah, also make sure your notebooks and your other console UIs are actually within the same GCP project. If you are a GCP user, sometimes that's going to be a problem to confuse your previous personal project with the QuickLab project. So my suggestion is to use incognito windows and open everything in that incognito window in the same session. So make sure you have the same GCP project opened everywhere. Awesome. Okay, so Fion's question is field to precondition service count. So service account is, you can think of it as your user account. You use this service account and the credentials to get access to everything from your Jupyter notebook. So it turns out you have problem accessing to the GCS bucket you just created, which usually not the case. Can you go back to the console UI and to look at your GCS bucket, this Fion 0614-2021, and to check if you have write access to this bucket? So I can show example here. So here is my bucket, right? So I created within this Quick Lab project. His name is Alvin Zhu 0614-2021. And if you click this bucket, there have a permission tab, permissions tab. And in this permissions tab, it should have your service account listed. So for me, I think it's this one, the first one. And for you, that's the service account. Service 9607. Yeah, just to make sure you have the permission to get access to the bucket. So if you see that, also make sure you have storage legacy bucket owner or storage legacy object owner authentications or say roles in there. Yeah, so another thing I want to check is go back to configuration tab and try to make sure the permission access control is uniform. So you don't have different access control for different objects in your bucket. Okay. Ooh, so yeah, another way to quickly fix this is probably you need to create a new bucket. So go back to the cell where I indicated create your bucket. Sorry, go back to the above cell where the bucket name and try to use a new bucket name there. So I see your bucket is called Fion 0614 blah blah. So you can just add a quick suffix to your bucket and create a new bucket to see if that works for you.
So Elvin, this is Chanchal. Hey, I have to go to that other workshop. So it looks like there won't be much time besides the XGBoost today.
Right.
We end around 4 p.m. our time. So tomorrow morning we'll start at 10 a.m. and we'll go through the Qflow setup, try to get that done if you can before. and we'll start with Qflow. Is that okay?
Sounds great.
Thank you.
Yeah, thank you. Okay, so let me check my Vertex AI training to see if any of the jobs has been finished. Cool, so you can see my ordinary training. Okay, awesome. So Fion's new bucket works. That's great news. And yeah, you can see my custom jobs is finished. My hyperparameter turning job is still running. And by clicking into it, you can see more details. You can see my trial ID 1 and 2 has been finished. I have IOC or AUC 0.9, etc. It's pretty high. You can see those hyperparameters configuration to get those numbers. And I think trial ID 3 and 4 is still running. You can see the CPU utilizations, memory utilization as well. If you configure GPU, probably you can also see the GPU utilization from dashboard, which is good. Pretty cool. And if you click any of the logs, you can actually see the logs of the virtual machine working on your current job. So yeah, there may be some errors. Don't be intimidated by those. Those are like just the regular TensorFlow random errors. Every time I run TensorFlow or importing TensorFlow, it just throw some bunch of errors there. And you can see the XGBoost job has been completed successfully. And so we should be very quickly seeing the hyperparameter tuning job to be done. Okay, so you see trial ID 3 is finished. We just wait for the last trial here. Yeah, you only needed 4 trials because my configuration, go back to the Jupyter Lab notebook. When I configure the hyperparameter tuning job, here in this section, I see max trial count is 4. If you are training a real model, doing the real world machine learning problem, probably you need much more than 4 trials to get the best combination. You can try 100 or something like that. Yeah, replica count and parallel trial count. So replica count is when you are doing distributed training. So for example, you wanted the training to be faster, you can parallel 4 workers to train your machine learning model at the same time. So those 4 workers will work on the single trial. And the parallel trial count means like you can have, for example, you have 100 total trials. You can have parallel trial count equals 10. So it will run 10 trials at the same time. And based on the previous 10 trials, the next 10 trials, like 11 to 20, will based on the metric and performance of the previous 10 trials and so on. So you are actually paralleling your hyperparameter tuning trials. But the replica count is just a way to increase the speed by using more machine. Okay, so I don't think we have tons of stuff left. So the only thing left is just train with your tuned parameters and deploy the model to a endpoint. I think some of you are still waiting for the hyperparameter tuning job to be finished. So shall we take about 10 minutes break and come back later? Sounds good? Awesome. Okay, see you guys in 10 minutes. Hey, Lad, can you show me the error messages? Hey, Natasha, if your hypertune job is finished, you can go ahead and run the following cell, which just redo the ordinary Vertex AI training using the hyperparameter you just found out. You just found out the best combination of hyperparameters, and you just rerun the training job again. Awesome.
Hey, Arvind, can I share my screen with you?
Hey, yes, sure. Please go ahead.
But I think you need to disable your sharing.
Oh, okay. Yeah, let me stop sharing. So I can see a bunch of error messages from TensorFlow. That is when you are importing TensorFlow or say initiating the virtual machine, but it doesn't matter. So I think your job can still finish without no problem. Can you scroll down to see if there's any other error messages there? Yeah, so those are just the warnings saying some of the packages are deprecated or something like that.
So
And
the error
I
message
think
won't
it's
be
still,
any problem?
yeah, this should be no problem. And I think you are still waiting for the XGBoost to start. I haven't seen any messages from actually running the XGBoost training, so you should probably wait for a longer while. So this is your hyperparameter tuning job, right?
No, this is my training job.
Oh, okay. Yeah, while you're waiting, you can start a hyperparameter tuning job as well. So they can run in the same time without conflicting each other.
Oh,
Save you
okay.
some
So I
time.
can
Yeah.
schedule that. I don't have to wait for this.
You don't have to wait for it. Yeah. That's a good thing
Oh,
about Vertex AI, because you have endless resources at your disposal.
okay, I'll do that.
Yeah.
Thanks.
No problem. Hey, to answer Natasha's question, you have a get index error. So that is probably because you need to run the cells above it again. So just run the cells saying check the status of a long-running operation with Google API client. Try to run that again. Because last time you ran it, probably the hyperparameter tuning is not finished. So it doesn't give you the full information. The one above, the get, sorry. So you are trying to run the get hyperparameter associated with the best metrics, right? So the one cell above is check the status of long-running operations with Google API. Try to run that again. So last time you ran it, probably the job status is, for example, job state pending or job state running or something like that. Make sure you see a job state succeed. Awesome. Yeah, so you can go ahead, Natasha, you can go ahead and run the training with tuned parameters.
Alvin, didn't we change batch size to booster in the hyperparameter tuning cell?
Yes, I just did that, but you can leave it as it is. So the only thing matters is like batch size. Under batch size, you see the parameter ID. That is booster. That's the only thing that matters. So yeah, the batch size is probably a bad argument, variable name. I forget to change. But if you change the batch size to booster, make sure you also change the batch size to booster in the parameter list below. Let me share my screen really quick. So did you see my screen?
Yes, I can.
Awesome. Okay, so here's a booster, right? So that's the only thing that matters. So this used to be batch size. You can change it to booster, but also change the batch size to booster here.
Okay, got it.
Right?
Thanks.
Yeah, no problem. So an estimator usually should be an integer, like number of estimators to use. If you have problem of flow type, let me see, how can I fix that? So the complaint about flow type, is this in hyperparameter tuning or just a regular training job?
It is using the tuned hyperparameter to train the model.
Oh, okay. So let me try
all the way down,
run that to see if I have the same problem. Okay, I got the same thing. Okay, I used to run this with no problem, but I think the thing is max depth is 0.6 and an estimator is 150.0. So sorry, 6.0 and 150.0. So that sounds like a float number to me. So probably we need to convert those into integers. I think we can do this. So back to the get parameters associated with the best metrics. Just add integer to change the data type. Let me see if I can fix that.
Byte or Unicode.
Okay, let me try strings. Sometimes they have very particular requirement for those kind of things. Okay, yeah, sorry about that. And I just copy paste these two lines to the chat. So you need to convert those to integers and then to strings to avoid those messages. Sorry about that. Yeah, okay, I think 10 minutes has passed. So anybody haven't done so, please go ahead. If your hyperparameter tuning job is finished, just try to run the cell beginning from this one. Check the status of long-running operation with Google API client, and it will give you a response. Make sure you've seen job state succeed. That means your hyperparameter tuning job has been successfully finished. Then you can go ahead and try to run the job again using the best metrics. There's 2 lines of code is has some bugs, so I just copy paste here in the chat. So make sure the max steps and n estimators used here are strings, not float numbers. And you can go ahead and run the training jobs again. Yeah, sometimes the training job can be on pending for a very long time. That's based on like how GCP figured out the resource for you to run your training. Usually, if you just finish the training and you have a VM idling, and you can start the next training really quick. But if the training has been finished for a while and the resource has been relocated to somebody else, and you probably need to wait for it a little bit longer. Yeah, so to answer the question about once your hyperparameter tuning is finished, you can go ahead and run the next cell, which is check the status for running operation with Google API client. You can start running this cell and make sure you've seen this. Oh, sorry. Yeah, make sure you'll see this job state to succeed. And you can go ahead and run the next cell, get the hyperparameters with best metrics. So I just updated these two lines. Make sure those max steps and estimators are strings instead of floats. And you can run another training job there. You can run all these cells and stop before the deploy the model. The total job you can run is actually, I don't think there's a limit for your total job you can run. If you are running regular Vertex AI training, you can run as many as you want. If you are running hyperparameter tuning job, you can configure the max number of count to, like, for example, 100 or some larger numbers. And also you can parallel those hyperparameter tuning jobs, like different trials with any number less than that. If you have like a total number of trials 100 and you parallel 100, doesn't make any sense because you don't know the metrics beforehand. So it's not actually tuning the hyperparameter for you. Yeah, Andy, to answer your question, the overhead latency is actually have high variance based on the availability of the resources, and GCP only charges you to the real jobs running. So if it doesn't find a machine for you and you wait for 1 hour, it doesn't charge you money for that. Yeah, you can see my job is also still pending. I'm not sure it's us or somebody else. I think that there's going to be a surge in the GCP resource requirements, maybe.
Hey, sorry, I think I just missed a step somewhere up there because I got the pending status and then eventually it returned and it gave me a file not found error. So is there a step somewhere in there that I have to configure the core.py?
You have finished the hyperparameter tuning, right?
Yes. But then I did
so
the check status. The check the status of long running operation.
Right. That should be correct. And you have changed those two lines, like the max steps and estimators to strings, right?
Yes. Yes.
Okay. Yeah, there should be no steps missing from then.
And then I got the index 0 out of range error.
Oh, so if you get an index 0 range error, that means you need to rerun the long running operation cell again.
Mm-hmm. And then I did, and the status failed. It says state failed because of the file not found error.
So you can successfully run the second cell, which say get the hyperparameter associated with the best matrix, right?
Get the hyperparameter with best matrix. No, that one is giving me index out of range.
Oh, okay.
That's because the previous step failed. The check status one says the status failed. And then the status failed is because there was an error on missing file. I mean, if it's too complicated, I mean, I probably missed a step somewhere up there, I think.
I got you. So I think somehow maybe you have different hyperparameter job names. That's the one possibility. So just type out or print your HPT job name there. I'm highlighting this variable in my screen, if you can see it.
Yeah.
Make sure this job name has the same ID as your hyperparameter tuning job. So go back to the UI console and say if this ID matches the UI console hyperparameter tuning job ID.
Okay.
Yeah, they should be matching each other, I guess.
Okay.
Yeah. So for example, mine is 339 and a bunch of numbers. It's also 339. Yeah.
Okay, thank you.
And does it solve the problem? So I think the training job pending. Oh, mine is running. Cool. Anybody else running? My status just changed from pending to running. Awesome. Yeah, I see people got to succeed. Yeah, I'm not sure we still have time to cover the model deployment. And once you have finished the final round of running, you can go ahead yourself and try to deploy the model to Vertex AI. So to deploy model means you have configured a endpoint, which is a VM. mount your model on top of the VM and ready to be used for prediction. So you can fire some API requests to your endpoint, and it will give you a classification result for you, which is awesome. And there's several steps involved into in deployment of the model. So first, you need to create a endpoint. Also, you need to import, or say, export, I don't know. So just move your model artifacts into Vertex AI. So once your model is trained by Vertex AI, it's not automatically imported. And it's saved into the GCS path you configured. And you need to import the model artifacts to Vertex AI. So once you have import model, once you have created endpoint, then you need to deploy the model to endpoint. That's another step. So 3 steps. And you have the model ready to be used for prediction. Another point I want to cover is why you want to run hyperparameter tuning and then another training job. So usually for data scientists, they just use smaller iterations or a smaller number of epochs to run hyperparameter tuning jobs. And once you find the best combination of hyperparameters, you just train with your hyperparameter with a larger iteration or epochs. So that will give you a model with a best train. So that's why we need to train 2 times. So for training right now, we don't have a choice to have a dedicated server to reduce the waiting time, because usually training are not time sensitive. So for production or enterprises who uses GCP, the data scientists usually go ahead and train a model and use that model, and they will do retraining based on data shifts or variance once a month or once a week, something like that. So training is usually not so much time sensitive. But for prediction, usually we need a very quick response. So we need a VM ready to be used. That's why we need to deploy a model to the endpoint. And from there, there's a dedicated VM always running and ready to be used for prediction, and the user can fire requests with very low latencies. Okay, cool. So my final training is finished. I have this model in my GCS path. So once you training with a Vertex AI, you have the model saved into the GCS path. And the path for that model should be your job DIR. And if I can go back to my cloud storage browser, check my bucket, check my XGB training job, and find the latest one. I should see a model.bst, which is a model artifacts for XGBoost, staying here in my GCS. So as a following step, I just to import model into Vertex and create an endpoint and deploy it. So I just go ahead and do that. So here you need to configure your model name. Me just call it my first XGBoost model. XGBoost model. And here we also have the base container image. Here I just choose XGBoost CPU you don't need to change that. You can use the same thing. The job dir is where my model BST stays. So this step is just to upload the model BST to Vertex AI. Once it's uploaded, you can go back to Vertex AI and see models. From the console, you should see I have a model available to me here. You can also do the same thing without the code. You can say import, give it a name, UI import model, and specify region, and then say you want to import model from a preview container. That's what we have done. And framework should be XGBoost. Version here, I just give it 1.3. For the bucket path, I should configure it to be this one. Always choose a folder instead of the file name. So it should be the folder containing the file, and click import. So that is another way of importing models. It's equivalent to what we have done here with the code. And after importing, we go ahead and create an endpoint. It takes a while, but it will create an endpoint for you. And just to go back to the console, you see I have created a model using the UI and clicking buttons. It's the same thing as importing from the code. Let's go to the endpoints. And you can see I created a new endpoint here. That's where I want to deploy my model. And I click deploy the model. I run this out. It will deploy the model to the endpoint. And it will be running a VM here and ready to be used for prediction. Once the model is deployed, then you can use it for online prediction. But you don't have to deploy a model for batch prediction. To do batch prediction, you only need the model artifacts, which is a BST file. So the difference between online and batch is just the online has minimized latencies because it always have a VM running and hearing. So if you want to do online prediction and you deploy a model to the endpoint, there's always a VM running. So you will also be charged by the VM. So if you always have a VM running, you're probably going to be charged all the time based on what kind of VM is running. If it has GPU, it has like a large CPU, you will be charged differently already. So if you only care about doing batch prediction, you can avoid deployment and save some money. Yeah, so deploy model to endpoint takes a while, so stay put and wait for it to be done. So mine is also still running. You will see information here, say endpoints, see the endpoints dashboard, and there's a model 0. So it means I haven't had a model deployed to the endpoint yet. And let's do refresh. Oh, okay, cool. I have a model deployed. So that should be ready. But here it's still running. I don't know why. Maybe because the model wait. Yeah, I think that's the problem. So if you are sure the model has already been deployed successfully, let's see. I'll just force stop this cell because from the UI, I see the model has already been deployed. Let me try to do a prediction. Just to run the prediction cell to see if I get any results. Empty post. Why it's empty? Right. So to answer Jack's question, 400 error not located in the US. So that's when you are creating the bucket. You have to specify the bucket to be regional instead of the multi-regional. So US means it's a multi-regional, and the US Central one is regional. So you can create a new bucket if you want. There's two ways of doing it. You can either in the console UI cloud storage dashboard, cloud storage browser, create a bucket, and give it bucket name. And here, try to notice here the you should specify region, not multi-region, and specify this as US Central 1, and you should be good to go. Another way of doing it is to go back to the previous cell. There's one cell saying this GSUtil, that's a cloud storage utility function, and MB means make bucket, and L region, here region is the US Central 1, and you give it a bucket name, and it will also create a bucket for you in US Central 1 as well. So yeah, just to make sure it's regional, not multi-region. Yeah. How to copy model from old bucket to new bucket? There's multiple ways doing it, and I think the most easy way to do is still using GSUtil. So you can do GSUtil CP, which means copy, and your old GS path and your new GS path. It's like a copy in Linux, but with a GSUtil at the beginning. Yeah, the prediction, I have some problem with it. So let me figure this out, and probably I can give you guys an update tomorrow. So it used to be running for me. Maybe the GCS, sorry, the GCP setup is different. Yeah, I think we have reached the time, and I think most of people have already reached the last step where you train your final model and try to deploy the model to endpoint. So I think that's a good sign. And thank you everyone for joining today's meeting. It's also a learning for me as well. So thank you for asking all these awesome questions and pointing out the bugs I have in the code. Always happen in the real-time demos. So yeah, thank you very much. And I'll see you guys tomorrow.
Thank you, Alvin. Thank you so much, everybody. We will see everybody tomorrow. Bye.
Awesome. And tomorrow we'll start up with the GKE setup, and we'll go from there.
Sounds good. Bye, everybody.
Thank you.
Bye, guys.